This is Charles Ely, and this is the 11th session. What I'd like to do, if possible, Dimitri, is this is the 11th session that we've got. Um, we're going to finish the HVAC secondary systems and try to get through the HVAC primary systems. One thing that I am going to do, though, is I'm going to postpone until next week a discussion on the equipment performance curves and put that into session 12. This gets into a lot of issues, and the performance curves are related to all kinds of HVAC equipment, from chillers to towers to boilers to furnaces to DX systems. And we'll cover that in more detail next week. So I'm going to kind of skim over that this time. Last week, John covered through fan systems, section 6.6.3. Today, we're going to move through section 6.4 through 6.7. Starting with outside air controls, there's one set of outside air control building descriptors that deal with outside air. The maximum outside air ratio. This would be a limit, for instance, if an HVAC system didn't have the capability of bringing in 100% outside air, be a ratio. There's the design air outside air ratio, which is the outside air at design conditions divided by the total supply air at design conditions. And then there's the outside air control method, which can be based either on the average zone or the critical zone. And then you get into outside air economizers, which are also in this section. And there's four building descriptors: the control type, which is either fixed dry bulb, differential dry bulb, fixed enthalpy, or differential enthalpy. There's the economizer high temperature lockout and low temperature lockouts. These are the temperatures above which and below which the economizer returns to the minimum outside air position. And then there's an economizer high enthalpy lockout, which is applicable when you use either fixed enthalpy or differential enthalpy. For the baseline system, the economizer is determined by the system type, and there's 8 baseline system types shown here. For most systems, well, actually, for systems 1 and 2, there's no economizer requirement, but for all the others, a differential dry bulb economizer is required. There's exceptions, however, for climate zones 1A through 4A and for climate zone 1B. Many of the requirements that we're going to go through today are keyed to these system types. So just keep the system map in mind as we go through this material. Moving on to cooling systems, these are the building descriptors. Total the cooling source, which can be chilled water or DX, cooling capacity, sensible capacity, cooling adjustment curves, coil bypass factor, and the coil bypass adjustment curve, excuse me. What I've done through this presentation is I've shown in red next to each building descriptor what the baseline system specifications are. So, for instance, the cooling source is a DX for systems 1 through 6, and it's chilled water for systems 7 and 8. Systems are oversized 15%. The baseline systems always use the default performance curves for capacity, bypass, efficiency, and so forth. For DX systems, these are the building descriptors: the cooling efficiency, the efficiency adjustment curve. There's an unloading ratio and a minimum hot gas bypass ratio, which are not applicable for the building systems, or for the baseline systems, I should say. And again, DX applies for baseline systems 1 through 6, and I've indicated what the baseline building values are in red next to each building descriptor. The condenser type is always an air-cooled condenser for systems 1 through 6. For evaporative cooling, these building descriptors are not applicable to the baseline building, since it never has an evaporative cooling system. But there's a evap cooling type, which can be direct, indirect, or integrated and non-integrated, or any combination of those. There's the effectiveness in the direct stage, the indirect stage. There's performance curves that modify the effectiveness for part load conditions. And there's other inputs dealing, or building descriptors dealing with auxiliary cooling power and any scavenger air source that's used. When you have an evaporative condenser, again, this is not applicable for the baseline building, but in this case, the building descriptors include the fan power for the evaporative condenser, its effectiveness, which is its ability to reach wet bulb temperature, and the operation range. Moving on to heating systems, building descriptors include the source, which is the source of heating, furnace, so forth. There's a preheat coil, and there's the heating coils, which are, in the case of heating, these are oversized by 25%. The heating source for the baseline building depends, of course, on the baseline building system type. It could be a boiler, it could be a furnace, or it could be a heat pump, depending on which system type is mapped for the rated building. For furnaces, which are used for a couple of the systems, systems 1 and 3 use furnaces. The building descriptors include the capacity of the furnace, its efficiency, a part load efficiency curve, which modifies the efficiency for part load conditions, the presence of a pilot, and whether or not there's any fans in the case of mechanical assisted combustion. The capacity, of course, is oversized by 25%. The efficiency is taken from 90.1 for the baseline system, and the part load efficiency curves use the defaults. There's no pilot in the baseline system, and nor is there any fan powered combustion. Heat pumps have quite a lot of building descriptors. There's the capacity, efficiency, and adjustment curves. Capacity, again, is oversized by 25%. The efficiency is taken from 90.1, and the default adjustment curves are used for the baseline system. Heat pumps are used in baseline systems 2 and 4, and again, I'm showing the baseline specifications in red next to each of the building descriptors. There's building descriptors dealing with supplemental heating, which would come on when temperatures drop and the heat pump itself is not capable of meeting load. The source for supplemental heating in the baseline building is electric resistance, and its capacity is auto-sized. There are building descriptors dealing with how the coil is defrosted. There's 4 choices for mechanism: hot gas on demand or timed, electric resistance on demand or timed. And the baseline system uses hot gas timed on 3.5-minute cycles. There's also building descriptors dealing with the crankcase heater. This is some systems have these, but the baseline system does not. This is a small, generally electric resistance heater that's in the crankcase to keep the refrigerants from migrating. Heat recovery applies only to the baseline building in special cases. One building descriptor is the effectiveness of the heat recovery, and this when heat recovery is required, which is for, I believe, systems that have more than 70% outside air ratio and more than 5,000 CFM. The effectiveness that's required is 50%. When you've got condenser heat recovery, the effectiveness increases to 60%. There's another building descriptor that indicates where the recovered heat is directed, either to reheat coils or to water heating. For 24-hour operations, the baseline building would direct the recovered heat to water heating. Moving on to humidity controls and devices. These again only apply in special cases to the baseline building. The first building descriptor is the humidifier type, whether it's hot water, steam, electric, or evaporative. For the baseline building, this is what we call neutral dependent, which means it takes its value based on the rated building. There's also a humidistat maximum setting. This too is neutral dependent, and the minimum setting is neutral dependent. So basically the rules here are if the rated building has a need for humidification, then the baseline building assumes those same conditions. I'm not going to spend much time on desiccant. It's not applicable to the baseline building, but there's a number of building descriptors which are used when you have a form of desiccant dehumidification. So now I want to take the rest of the time to discuss the HVAC primary systems. These include boilers, chillers, towers, waterside economizers, pumps, thermal storage, heat recovery from chillers, and techniques for plant management. Boilers are required are used actually in baseline systems 1, 5, and 7. The fuel is the same as the rated building. The type is hot water for the baseline building. The draft type is natural draft, or atmospheric, it's sometimes called. The number of boilers depends on the square footage. If the area served is 15,000 square feet or less, there's just one boiler. Otherwise, there's 2 equally sized boilers. The boiler heat loss is 0 for fuel-fired boilers, since this is already included in the AFUE for the boiler, but you add 2% for electric boilers or for heat exchangers. The design capacity is oversized 25% based on loads. The efficiency type, which would be either AFUE or thermal efficiency, would be, I think for most boilers, it would be thermal efficiency, is neutral dependent. The boiler efficiency is, for the baseline, is taken from 90.1. The adjustment curves for part load and unloading use the defaults. Temperature is, the hot water supply temperature is 180 degrees with a return of 130 degrees, but it's reset down to 150 degrees when the outside temperature is 50 degrees or warmer, and there's still a heating load in the building. And as I mentioned, baseline systems 1, 5, and 7 all have boilers. Okay, moving on to chillers. The building descriptors include name, type, the number, the fuel type, etc. Baseline systems 7 and 8 have chillers, and the specification for the baseline I've shown in red. The type of chillers depends on the load. For smaller systems, it's a screw chiller. For larger systems, the baseline is a centrifugal. And the number of chillers also depend on load. There's a table in COMNET, which is also the same table from 90.1, which indicates the number and type of chillers based on the load. So if it's less than or equal to 300 tons, it's 1 screw. If it's more than 600 tons, there's 2 centrifugals, and in the middle there's two screws. They're all water cooled. They're oversized 15%, like all cooling equipment. The rated efficiency for the baseline is taken from 90.1. The default chiller adjustment curves for capacity and efficiency are taken from the COMNET defaults, and as I mentioned, we'll cover those equipment curves in more detail next week. Chilled water is in the baseline is delivered at 44 degrees Fahrenheit and returned at 56, but that temperature is reset up to 54 degrees when the outdoor temperature drops to 60. The condenser type is, of course, water cooled, and so forth. For towers, baseline systems 7 and 8 both have towers, and each chiller has a tower matched to it, and each tower has 1 cell. So so for more than 600 tons, there's 2 chillers, so there'd be 2 towers. For less than 300 tons, there'd be 1 chiller, so there'd be 1 tower. The tower type is the first building descriptor, and for the baseline, it's an open axial fan type. The tower is oversized. The capacity is oversized 15%, and this is based on a 85-degree entering condenser water temperature design conditions. There's one cell per tower and 1 tower per chiller. The horsepower is not used because it's specified in another manner. The designed wet bulb is the same as the rated building. The entering water temperature is 85 degrees or 10 degrees above designed wet bulb, whichever is less. And the designed return temperature is 95 degrees or for a range of 10 degrees Fahrenheit. The default adjustment curves are used, and the set point is fixed at 70 degrees Fahrenheit. It doesn't reset in the baseline building. The baseline building tower has a 2-speed fan for some modulation, and the low-speed airflow ratio is 0.5, and at that conditions, the kW is ratio is 0.3, and the default adjustment curves are used, and as I mentioned, we'll cover those in a bit more detail next week. Waterside economizers, here are the building descriptors, the type of economizer, the heat exchanger effectiveness, the maximum dry bulb temperature, minimum chilled water supply, so forth. The baseline systems do not have waterside economizers, so these building descriptors would only apply to the rated building. Moving on to pumps, there are a lot of pumps in the baseline system. Systems 5, 7, 1, 5, 7, and 8 all have pumps of one type or another. The building descriptors are listed here, the name, the service, which is what the pump is used for, the number of pumps. The baseline system has one condenser water pump per chiller, one hot water pump, and one chilled water pump. For hot water, it's a primary only system for water loop design, and for chilled water, it's a primary secondary system. Pumps for the baseline building are modeled using a power per unit flow method. That's specified to be 19 watts per GPM for condenser water and 22 watts per GPM for chilled water. Since the power per unit flow method is used, the impeller efficiency, motor efficiency, pump head, and so forth are not used for the baseline building, but those could be specified for the rated building. The minimum speed for the pump is its minimum flow when, and this applies just to variable speed drives. This is for the baseline building. This is 0.1 when variable speed is required for the secondary system. The design flow is specified at 2 GPM per ton for chilled water and 2.5 for condenser water. And for the secondary system, it would of course vary because a VSD is required for the secondary system. And again, the part load curve uses the COMNET defaults. Thermal storage is not applicable for the baseline building, and as a result, we really haven't laid out any building descriptors for this. There's many ways to model thermal storage, and at the moment, COMNET really doesn't delve into that in any depth at all. But heat recovery, we do have some building descriptors, but again, this is not applicable for the baseline building system. The building descriptors include the name, the device type, where you're getting the heat. It could come from a double bundle chiller, a generator, an engine-driven chiller, an air conditioning unit, or from commercial refrigeration systems. And then you indicate where the recovered heat is directed to the hot water system, to the service water heating system, space heating, or to some process load. Finally, plant management. This is when you've got multiple pieces of equipment. This indicates how they're sequenced, and for the type of equipment that's managed is neutral dependent, which means that whatever you do in your rated building, you do the same in your baseline building. The schedule is the schedule of operation, say for multiple chillers or multiple boilers. And when the baseline building has multiple equipment, it's staged. So the first one would come on, and the boilers and chillers are all equal size. So the first one would come on and run until it's no longer capable of meeting load, and then the second one would come on. the equipment is operated based on demand. So I know there's probably lots of questions. We raced through quite a bit of material here. It's all laid out, of course, in the MGP in much more detail. But I wanted to get through it fairly quickly so that we would have plenty of time for questions and discussion. So I'll stop there.